Hello everyone. In this video, we are going to discuss one of the very important topics of metals and non-metals, that is extraction of metal. So it is studied under a topic called metallurgy. Okay, when we talk about metallurgy, metallurgy is the branch of science which deals with the study of extraction of metal from its ore. Okay, so there are certain terms which is there in this topic. So let's discuss first one, minerals. Okay, so naturally occurring chemical substances in the earth crust, they are obtained by minings. So in short, we can say that minerals are naturally occurring inorganic substances like mica. Okay, let's talk about ore. Next important topic, minerals from which metals are extracted. That is called as ore. So how we define a ore? An ore is a mineral from which metal can be extracted economically or conveniently. For example, iron ore, which is hematite, bauxite, which is a ore of aluminium. Okay, copper pyrite, ore of copper. Yes or no? So, ores that are abundant and do not produce polluting gases undergo metallurgy. Okay, next, gangue. So, gangues are nothing but the impurities present inside the ore. Okay, na? So, you can see ores containing, contaminated with earthly or undesired materials. Or simply, we can say the impurities present in the ore is called as gangue. Okay, so here we have to remove the gangue. Okay, we are adding some substance that is called as flux. So flux is the substance which is added to remove the impurities. Okay, now see, during the extraction of metal from the ore, certain unwanted substance is obtained, that is called as slag. Okay, that also you should remember. So what happens? Gangue plus flux gives slag. Slag is the unwanted material which is obtained during the extraction of metal. Yes or no? So here you can see some ores, some metals, and their ores are given. Aluminium. The main ore is what? Bauxite. The formula is Al2O3 dot 2H2O. Cryolite. Na3AlF6. These are the ores of aluminium. Okay. Iron. The main ore of iron is what? Hematite. The formula is Fe2O3. Magnetite, Fe3O4. Siderite, FeCO3. Iron pyrite, FeS2. Okay. Zinc. Zinc blend, ZNS. Okay. And calamine, zincite, you can see. Okay. So these are the main ores of few elements. Okay. You should remember the main ore of aluminum is bauxite. The formula is there Al2O3 dot 2H2, and hematite is the main ore of iron, which is Fe2O3. Yes or no? Okay. So we have one flow chart. Okay. For the extraction of metal, we'll discuss this flow chart first. Try to understand ore. When we talk about ore, okay, so we have ore of different metals, yes or no? And we also know that metals have different reactivities. Some are high reactive, some are medium reactive, some are low reactive. So we have to follow the different procedure for the extraction of metal. Yes or no? How we are taking out the metal from the ore. So for medium reactivity, there is a separate process. For low reactivity, again there is another methods, and high reactivity separate methods are there. So here in this flow chart we discuss first okay, ore. So when we talk about the extraction of metal, we have generally four steps. Okay, generally, okay, in the extraction of metal from the ore, we have a four method. First one is called as concentration of ore. Okay, concentration of ore, are also called as dressing of ore. In this method, the basic impurities are removed. Second one is what? Conversion of concentrated ore into oxide. Conversion of concentrated ore into oxide. Okay. Third one is what? Reduction of metal oxide into metal. Reduction process. And the fourth one is what? Refining. We are going to discuss one by one, not an issue. Okay, so just remember these four steps, general four steps are there for the extraction of metal. So you can see extraction of crude metal from the ore. We have metals of high reactivity, metals of medium reactivity and metals of low reactivity. Okay, when we talk about metals of high reactivity, for example, potassium, sodium, yes or no? So they are in the form of halides and oxides. Okay, so we are doing the electrolysis of molten ore. For example, sodium ore, NaCl. So once you do the electrolysis, you will get the pure sodium. Okay, yes or no? For example, sodium, magnesium, aluminum. Yes or no? So this is how we are extracting the metals of high reactivity. Okay. Now this is very very important. Most of the metals falls under medium reactivity like iron, copper, aluminum, which is widely used in the day-to-day life. Yes or no? So these are the metals of medium reactivity. So generally these ores are in the form of carbonate ores or sulfide ores. So we are doing the concentration of ore. Concentration of ore means the basic impurities are removed. Here you can see concentration of ore is done for all the three types of metals. So concentration of ore, like we have some methods like hand picking is there, washing is there, that is called hydraulic washing, froth flotation is there, magnetic separation is there. So these are the methods by which we are removing the basic impurities present in the ore. Okay, froth flotation is generally used for sulfide ores. Okay, magnetic separation is used for the magnetite ore. Okay, now hydraulic washing is used for the heavier ores. Okay, so like that. First we will do the concentration of ore. Yes or no? So basic impurities are removed. Second step is what? Metals of medium reactivity. We have to convert these concentrated ore into oxide. Okay, conversion of concentrated ore into oxide. So generally these ores are in the two forms. First is what? Carbonate, other is sulfide. Yes or no? So for carbonate ore we are using calcination. Okay. And for sulfide ore we are doing roasting. In both the methods we will get the oxide of metal. Very very important. We will discuss in detail what is calcination, what is roasting. Calcination is generally used for carbonate ores. Okay, here ore is heated strongly in the absence of air, whereas sulfide ores are used for roasting is used for sulfide ores. Here ore is heated strongly in the presence of air. Okay, now we will discuss later. So when we do the calcination roasting, we will get the oxide of metal. After that oxide of metal, we have to do the reduction of metal oxide into metal. So next step is what? Reduction of metal. The metal which is reduced is not 100% pure. Okay, it may be 95%, 96% pure. So we have to do the purification of the metal or refining of the metal. So we have again different methods are there for refining: distillation, polling, liquefaction, electrolytic refining. In your syllabus, this is the most important, electrolytic refining. That also we will discuss. Now, when we talk about the metals of low reactivity, okay, low reactivity. When we talk about like silver, okay, gold, okay, now mercury. So we can see first we will do the concentration of ore. Okay, concentration of ore is there for all types of metal. Okay, high reactive, medium reactive, and low reactive. So we will talk about the low reactive one. Generally, they are present in the sulfide forms. They are in the sulfide ores actually. So we are following the roasting. Okay, when we do the roasting of sulfide ores, we will get the oxides of such metal, and then we will do the reduction. Okay, once you do the reduction, you will get the metal, and after that we can go with the refining. So we can follow any one of the methods to refine the metals. Yes or no? So this is the flow chart. Okay, this may be asked for 3 marks. Okay, it is given in the NCERT textbooks also. Okay, so let's discuss one by one now. Okay, concentration of ore. Okay, so also known as dressing or benefaction, or also called as enrichment of ore. Enrichment of ore. Okay, so removal of the unwanted materials like sand, clays from the ore. Okay, takes place within this process. Okay, physical properties of compounds and can be present. Okay, below steps are selected. Actually, we have, I told you, different methods of concentration of force are there, like hydraulic washing, magnetic separation, froth flotation method, and leaching. Okay, leaching. Leaching is generally used for bauxite ore. Froth flotation method is used for sulfide ores. Okay, magnetic separation is used for the magnetite ore. Okay, either ore is magnetic in nature or it is impurities is magnetic in nature. Okay, hydraulic washing is used for the heavier ores like lead. Okay, next. Okay, So in detail it is there for ICSE 10 standard hydraulic passing. Okay, just being a good student you should just know what is hydraulic passing. So when ore or gangue have difference in the gravities, we use this process. Types of gravity separation also it is called as. Okay, an upward stream of running water washes the powdered ore. So here what happens? A jet of water is blown, so impurities are washed away. So the light gangue particles washed away and the heavier ores left behind. So no, so in this way the lighter impurities are washed away and heavier ores are remaining. So no, so here you can see. Next one. Magnetic separation. Here what happens? Either the gangue or the ore, one of these two gets attracted to the magnetic field. Okay, so ground ores on conveyor belt passes over a magnetic roller. You can see here two types of rollers are there. One is a non-magnetic roller, and next is what a magnetic roller. Here the ordered ore, okay, is allowed to pass through the conveyor belt. So there are two containers are there. So the magnetic particles will be only in this container and non-magnetic particles will be stored in this container. Yes or no? While moving. So here in this way the magnetic particles are separated from non-magnetic particles. Generally used for magnetite ore. Now we talk about the froth flotation method. Generally it is used for sulfide ores. Okay. So differential weighting of ore by the oil and impurities are there. Here what happens? We are using some iron oil froth stabilizers, we are using a collectors, we are using a and suspension of ore we are using a. It is crushed into fine powder, here you can see, and a compressed air is blown. Okay, this tank is not, so froth is collected. Once froth is collected, sulfide ores are lighter in nature actually. So it will come to the top surface. Okay, and froth stabilizer is also there. We are using a. So now this froth is collected and dried up. Okay, and impurities will settle down, the gangue will settle down at the bottom. Yes or no? So in this way you can see. So dissolved in water actually, gangue particles get weight by the water only. Okay, collectors dissolved in the fine oils, fatty acids or xanthates. Minerals particles get weight by the oils. Froth stabilizers are there, dissolved in the cresol and aniline stabilizes the froth. Okay, so that you have to remember. So froth, okay, you can see carries the mineral particles only, lighter and skimmed off. On drying, ore particles are recovered. Okay, in this way we are separating the sulfide ores. Yes or no? Now leaching we are using for the extraction of or concentration of bauxite ore. Here what happens? Used when ore is soluble in some suitable solvent like sodium hydroxide. Okay, so you can see here leaching of aluminum from the bauxite. Here ore, that is bauxite, has impurities which is SiO2 and iron oxide, titanium oxide. Yes or no? So Al2O3 leached out as sodium aluminate. How? Whenever we are dissolving in sodium hydroxide, only ore will dissolve, not the impurities. So Al2O3 will dissolve into this and it will form sodium aluminate. Okay, now what happens? A precipitation of hydrated Al2O3 to NaAlOH4, okay, plus CO2. What will happen when you do the precipitation? So we'll get the Al2O3 dot XH2O. Okay, now this precipitate is separated and if it is heated strongly, we get the pure alumina Al2O3. Okay, in this way that the concentration of bauxite is done. Now next important steps. Okay, once next step is what? A conversion of concentrated ore into oxide, which is there. Okay, very important. So we have, as we told you, that there are two types of ore. Okay, one is the carbonate ore, other is sulfide ore. So first we will discuss about the calcination. Okay, so what happens in calcination? The carbonate ores are heated strongly in the absence of air. For example, zinc carbonate. Okay, so zinc carbonate, what we are doing? Ore of zinc, we are heating strongly in the absence of air. So it gives you zinc oxide plus carbon dioxide. Yes or no? Similarly, calcium carbonate is there. So what will happen? Ore of calcium, we are heating strongly in the absence of air. This is the heat symbol. So it gives you water, calcium oxide plus carbon dioxide. Yes or no? So in the calcination, which gas is produced? The CO2 gas is produced. Okay. Now roasting. Roasting is used for what? It is used for sulfide ores. Here in this method, the sulfide ores are heated strongly in the presence of air. For example, you can say, okay, you can see zinc sulfide, okay, heated strongly in the presence of air O2, so it gives what, a zinc oxide plus sulfur dioxide. You can see the balanced reaction, 2ZnS plus 3O2 give you 2ZnO plus 2SO. Similarly, copper sulfide react with the heated strongly in the presence of oxygen, gives what, copper oxide and sulfur dioxide. So these are the two methods of conversion of carbonate ores or sulfide ore into their oxides. Okay, now this is the second step after the concentration. Next step is what, reduction of metal oxide into metal. So we have to finally get the metal, yes or no, like zinc, iron, copper. So we have to use the reduction of metal oxide into metal. So we have to use some method like by using reducing agent, self reduction. Okay, so one method I am explaining by using reducing agent. Okay, reducing agent in the sense like zinc ore is there, so zinc oxide is there. So we are using a coke. Coke is a reducing agent. So once you heat with coke, it gives you what, zinc plus carbon monoxide. Yes or no? So this is one of the methods, like zinc oxide is changed into zinc. Okay, another is what, a self reduction. What happens for copper oxide? Actually, copper oxide is heated with ore itself. What is the ore? Copper sulfide. So it will give you what, a copper plus sulfur dioxide. So these are the methods of conversion of metal oxide into metal. This is the third step. So now, and next last step is what, refining of metal. When we talk about refining of metal means we have purification of metal. Yes or no? So you can see here, refining of metals, we obtain high purity metals on refining. So we are using distillation. Generally, impure metals are evaporated and pure metals distillate. Okay, like generally we are using for zinc and mercury. Okay, which have low boiling points metal undergo distillation. Next, liquefaction method, what we are doing, okay, application for metals like tin, lead, okay. Okay, so application for metals like tin, lead, bismuth, so low boiling point, okay, metals we are using the liquefaction method. Okay, the pure metals, what happens, flows down. Here sloping earth is there, so low melting point metals will melt and will collect here. Okay, now molten metals will be there and impurities will not melt. Yes or no? No. For your scan, when we have a electro refining is also very very important. Electro refining. So generally we are using for most of the metal like iron, copper. So here what we are doing, impure metal, like for impure copper we are making anode and a strip of pure copper we are making what, a cathode. Let's take about the refining of copper. So generally what happens at anode, oxidation takes place. Oxidation means what? So these two metal plates are like, one is what, impure metal, other is what, a strip of pure metal. Yes or no? That is dipped into water. It's electrolyte. Like if it is copper, so we have to take the electrolyte of copper, that is copper sulfate, connected to a cell, negative and positive. Yes or no? Positive is called as, generally positive is called as anode. Positive is called as anode and negative is called as cathode. Negative is called as cathode. So generally at anode what happens? Oxidation happens. Oxidation takes place. Okay, so what will happen? The copper will lose the 2 electrons, become what, copper ions. So copper will dissolve into the solution, Cu2 plus. Okay, and at cathode reduction takes place. At cathode reduction takes place. Reduction means what? Gain of electrons. This copper ions from the solution will gain the 2 electron, okay, and become copper solid. Yes or no? So it will get deposited here, copper solid. Yes or no? So in this way, that all impure copper, okay, will from the anode, okay, the copper will come into the solution, okay, and again from copper ions will deposit in the cathode. Okay, all impurities will settle on at the bottom. Yes or no? So in this way, the metals are refined, especially copper. Okay, so here extraction of aluminum is there. We'll discuss separately. This is for ICSE 10th standard. Okay. I hope you understood these concepts of extraction of metal. Please share with your friends and subscribe the channel. Thank you.